Hi, I'm Mike Hoyer, HBK Applications Engineer, and this is a short video on setting up a T210 torque sensor for an electric drive test on a Genesis dynamic power analyzer. Before we get into setting up a T210 torque sensor, which is a custom solution for a Genesis power dynamic analyzer, we'll first talk about the more common torque sensors used, which are non-contact torque sensors, the T12 and the T40B, which both offer an RS422 torque and speed output. And in these cases, you would use a standard G070A torque RPM adapter. And in fact, the G070A offers two RS422 torque and speed inputs for two T12 and T40B sensors. Now the T12, T40B offer options for speed, direction, and reference pulse so that you can perform DQ0. Therefore, the G070A accepts the speed, direction, and reference signals so Genesis can perform the DQ0 calculation. So with this setup, you would use a cab 149-6 torque cable from the T12 or T40B to the G070A torque input. Likewise, you would use a cab 163-6 speed with reference pulse cable from the T12 or T40B to the G070A speed input. Now the G070A offers two RS422 torque and speed outputs for dyno control, and the G070A connects to a Genesis mainframe via the included DB44-pin cable. Now, with that review, let's get into the setting up of a T210 torque sensor, which is a shaft torque sensor, which offers RS422 on the torque output and a TTL speed output. So in this case, the Genesis Power Analyzer connection solution is a custom G070A S32 torque RPM adapter. Now this custom G070A S32 offers two RS422 torque inputs and two TTL speed inputs for two T210 sensors. Now the T210 offers an option for speed, direction, and reference pulse output to perform DQ0, and likewise the G070A S32 accepts the speed, direction, and reference pulse signals so Genesis can perform the DQ0 calculation. So with this setup, you would use a custom T210 G070A cable from the T210 to the G070A S32 torque RS422 and speed TTL inputs. Now the G070A S32 offers two RS422 torque outputs for dyno control. However, there are no speed outputs. We'll talk about some special cases for that in a moment. Now the G070A S32 connects to a Genesis mainframe via the included DB44-pin cable. So what we've just described in the previous slide is now shown here pictorially using a custom G070A S32 torque RPM adapter to interface one or two T210 shaft torque sensors to a Genesis dynamic power analyzer using one or two custom T210 G070A cables. Now you'll notice that the T210 sensors are powered via the torque RPM adapter's circular connector, which routes power to the T210 sensor via pin 6 and 5 on the torque input connector. Well, sometimes applications have unique requirements, so we'll address some of the special cases here, starting with the need for a speed RS422 output. So in this case, you would need to use a standard G070A torque RPM adapter and modify a standard T210 cable, part number 3-3301.0159. It's on the T210 datasheet, in order to adapt the setup shown here. So you'll also need to use a third-party TTL to RS422 converter in order to convert the T210 speed TTL output to RS422 for the standard G070A speed RS422 input. So in this special case, the solution offers up to 2 speed RS422 outputs via the standard G070A torque RPM adapter. So in this special case, the need for a speed TTL output, you would need to use the custom G070A S32 torque RPM adapter and modify a standard T210 cable, part number 3-3301.0159, in order to adapt to the setup shown here. Now you'll also need to use a third-party TTL distribution amp to distribute the T210 speed TTL output for both the custom G070A S32 speed input and the input for your dyno. For this special case, the need for a torque analog output, you would need to modify a standard T210 cable, part number 3-3301.0159, in order to adapt to any of the previously mentioned setups and utilize the analog torque signal available via pins C and D as outlined here in red. The custom torque RPM adapter and custom cable we've mentioned previously can be ordered separately or as a set as shown here in the list of part numbers. Now there's also a part number to modify an existing standard G070A torque RPM adapter to a custom G070A S32. In order to add the T210 to the Genesis Perception Sensor database, you can make a duplicate of a similar sensor and just update the parameters for the specific T210 sensor you're using. So in this example, we've set up a 10 Newton meter T210 10 kHz plus minus 5 kHz torque signal. In this example, we've set up a 1024 pulses per revolution for a 10 Newton meter T210 speed signal, knowing that this specific sensor has a maximum RPM of 20,000. So to calculate the sensitivity, we divide 20,000 RPM by 60 seconds to get the result in rotations per second, then multiply by 1024 pulses per revolution to obtain the number of pulses per second at 20,000 RPM, which results in 341.333 kilohertz. Well, the T210 parameters we've saved to the sensor database in the previous slides can now be selected within the Perception ePower Suite sheet or tab for torque and speed. So we can also adjust the spans for torque to 20 Newton meter to allow for a plus minus 10 Newton meter measurement, and speed to 40,000 RPM to allow for a plus minus 20,000 RPM measurement. And we're finally done. More details are available on our website at www.hbkworld.com, and for technical support, you can use the emails listed here for North America, support@usa.hbm.com, and worldwide, support@hbkworld.com.